Good morning, everybody. A very warm welcome to JET Celebration Day. It's great to see you all here. It's a real pleasure to welcome you to UKAEA's Culham campus to celebrate 40 years of science operations on the Joint European Torus, JET, which started in the summer of 1983 and ceased experiments in December last year, 2023. JET has been a magnificent machine, which has been at the very forefront of the field of fusion energy for decades and produced vast amounts of scientific results and valuable technical information. But today we are celebrating much more than a machine, great though it is. We are celebrating the extraordinary collaboration teams and people that made JET such a success. So we're delighted to be able to welcome back many of the JET people to share in these celebrations. We start today with speeches from our distinguished guests, Dr. Righi from the European Commission and Minister Bowie from the Department of Energy Security and Net Zero. They are going to speak here today in the JET building, the Torus Hall, and then we are going to move across to the marquee for a series of talks covering the story of JET. So to start us off, I'm very pleased to welcome Dr. Righi, Head of the Unit for Euratom for the European Commission and a previous researcher on JET.
Thank you very much. Dear team, thank you very much for your kind introduction. Ladies and gentlemen, dear colleagues, I'm delighted to be here today with you at Culham, at JET, to celebrate together 40 years of scientific operations of one of the world's iconic research facilities in the world. I'm also happy to meet again Minister Bowie, and I look forward to hearing what you're going to say after me. I also take the opportunity to say hello to our online audience, wherever you may be, because I'm sure there's a lot connected. So let me get stuck into this. The results achieved here during these 40 years are a foundation pillar of fusion energy research and innovation to develop its potential as a safe, sustainable, low-carbon energy source, showcasing the European leadership in this field. I therefore would like to start the celebrations by thanking all the scientists, engineers, technicians, support staff, contractors, everybody who in these 40 years dedicated their careers and so much of themselves to operate and exploit this wonderful machine. The original JET team, which you will allow me to add, including not only the Euratom and UKAEA staff, but also so many students who were formed in this open, truly European and international environment, and many visiting scientists around the world. The EFDA, and now the Eurofusion Consortium, and of course the UK Atomic Energy Authority. If you allow me to paraphrase a sentence from our colleague Dr. Pietro Barabaschi, who is now the ITER Director General, we all are part of one, capital letter one, JET team, and as such we are celebrating today. Allow me also to remember those colleagues who are no longer with us, to whom we owe so much, many of whom were our mentors, the pathfinders in this project, and no doubt are with us in our memories and hopefully are having a celebration of their own, because we stand on the shoulders of giants. I am here with two hats, because as head of Euratom research, I am the Commission representative, but I'm also privileged to be part of the One JET team. I arrived at JET in 1990, fresh from university, never been out of Italy before, for 3 months as a student assistant, and stayed for 7 years, until the end of 1997. I was asked to share photos of those years, but honestly, I was too busy working and enjoying myself to take pictures. I have, however, very vivid memories of those years. I stepped through the doors of the K1 foyer and never looked back. It was my first time out of Italy, and for me it was a wonderful adventure. The excitement of the PTE was still in the air, and I remember having to go to the control room to find someone and getting lost all the time because I couldn't find it. My first week here was full of exciting. I understood nothing. I wanted to know everything, and had fantastic headaches every single evening. It lasted a week. That was partly due to information overload, it's true, and partly to the effort of understanding the native English speakers, because I understood very quickly they clearly did not speak the slow English of the school courses. I graduated as a hardline theoretician, and my tools were pencil, paper, occasionally a computer. In those days I had the magnetic tapes, so you can carbon date me from that one. What use a facility like JET had for a theoretician in an operational division? Well, my mentor, David Start, thought this could work out, and I owe it to him, as well as to Jean Jacquinot, that they saw potential in me and gave me a chance. I took to operations like a duck to water, blended theory and experiment in one wonderful experience, and leading to the DT1. So I do not have photos, but I have a lot of fond and very vivid memories, the training, the sense of responsibility, the confidence, a career, and the lifelong friendships that JET gave me. Instead of the pictures, here is an enduring memory of my time here. Is this the one? This is my own notebook of the DT1 H-mode power threshold experiments, with all the waveforms, the reference pulses, the notes, the logs, the scribbles, everything. I have a series of these notebooks at home as a compulsive hoarder. I kept everything. And these are my memories, which I have partly digitized just before the COVID lockdown and emailed to prepare for the DT2. Of the DT1, I have one memory I want to share with you because it's a bit funny. It wasn't at the time, but it's funny now. Because I had the very dubious honor of having had the first disruption in an ICRF-heated 50-50 DT plasma in a totally Helm-free H mode. The plasma went Helm-free, confinement was so good, nothing escaped from it, and bang! It was a late shift, I did not sleep all night, I was so worried something might have gone wrong with the machine. So the following morning I walked in the control room, fully expecting Jacquinot to fire me on the spot. Okay, I was a contractor. But nothing happened, everything was good, everything was normal. So this machine was built to outlast us, and it showed through 40 years of operations. With time, as I became more familiar with its operations, the machine itself sort of took a life of its own for me, and I know it's weird. That is why for me, on top of all the fantastic diagnostics added and upgraded through the years by brilliantly inventive colleagues, I love the simplest, the microphones in the torus hall. For me, it was wonderful to listen to the whistling instabilities, the magnets growing while storing and releasing energy, the stiffening of the structures. It made JET alive in a way. And so much could be learned if only you listened very carefully. I could go on all day, so I know I'm not going to. So now allow me to wear my other hat. As a Commission representative, I'm proud to say that JET, the largest existing fusion device in the world, on which ITER is most closely modeled, was built and operated as a joint undertaking of the European Community from 1977 until the end of 1997 under the Euratom Research and Training Program. Again, I have no photos, but here is another record, the original JET documents, complete with all the statutes of the joint undertaking, the amendments, the rules, all the annotations of the lawyers. A colleague lent it to me, and I thank her if she's listening, she's watching, on a promise to return it complete without losing any of the post-its. Euratom continued its support under the new contract for the operation of the JET facilities with a total contribution of over 450 million euros. The NJOC, as it was called, closed at the end of October 2023, independently of the withdrawal of UK from the European Union, because together we demonstrated the facility's relevance for the European fusion effort. After this, European support continued indirectly through Eurofusion, but without a direct financial contribution. This allowed to complete the DT2 with its record 59 megajoules of stored energy, and the recent announcement of the 69 megajoules record during DT3. JET delivered until the very end, pushed by a very dedicated one JET team. These results have been counterpointed by the exceptional results of the nuclear ignition facility. Together, they have contributed to show and focus the interest of both the public and the policymakers, to show that fusion is closer to reality, and then we need to move forward. The counterpoint of JET and NIF results very much remind me of the scientific competition that happened 20, 30 years ago between JET and TFTR, which also pushed each other at the boundaries of what was possible in a very scientifically correct but very fierce way. This cues to one important message. JET exemplifies the power of European and international scientific collaboration at its best, and is the foundation of collaborations like ITER, the Eurofusion Consortium, and Fusion for Energy. The response to energy and climate challenges is a top EU priority. In the transition to a low-carbon society, fusion energy could, in the long term, play a significant role as a clean and limitless source of energy. Even with a future energy mix increasingly dominated by renewables, rightly so, the potential of fusion energy remains clear. The realization of fusion as a viable energy source remains a priority in the EU. Recognizing the significance of fusion energy, the European Union strongly supports both the integrated European effort and international collaboration through its Euratom Research and Training Program, as complementary program to Horizon Europe. Euratom has been the framework in which, for more than 60 years, knowledge and competence in nuclear science and technology have been developed in Europe, from basic research to innovative systems and solutions. The Euratom program currently foresees a budget of 583 million euros for the period 2021 to 2025 for fusion research and development. Most of the budget is implemented through the Eurofusion Consortium, the European Consortium for the Development of Fusion Energy. Eurofusion is a vital player, integrating the EU research fusion effort, contributing until now to the exploitation of JET, preparing teams for future ITER exploitation, and implementing the Eurofusion roadmap missions and training the next generation of fusion scientists and engineers. In this context, the Commission and the Council of the EU, in a joint statement, noted with regret that the United Kingdom decided not to associate the Euratom program and the Fusion for Energy joint undertaking. For the next period, starting in 2028, the EU institutions called emphatically the UK to participate in all the 4 programs. It had agreed in principle to participate too back in 2020. This will allow a truly European fusion community to continue its integrated efforts and to resolve the current ambiguous participation of the UK Atomic Energy Authority to Eurofusion and enable the UK's full reintegration in the construction and operation eventually of ITER. Now, change subject. Science should in principle remain without political boundaries, okay? And that's rightly so. Fusion research was the one example of international cooperation during the Cold War that did not know boundaries. This is why the current geopolitical situation is particularly painful, because we know how joyful it is to work together, irrespective of nationality, color, gender or creed, and we need to hope for better times ahead. JET and all the people here today have shown that this is possible and is worth doing. The success of fusion hinges on nurturing young talent in science and engineering, as well as a strong vocational training. Education and training are pivotal components of the Euratom program, ensuring a skilled workforce for the future. European researchers are also contributing to the JT60SA tokamak in Japan, optimizing the ITER research plan and working to make fusion energy a reality. The ITER construction remains a fantastic opportunity for the new generations of engineers and scientists to get to grips with a project of immense magnitude. And honestly, I wish I were 30 years younger. We are also living in interesting times because fusion research is today at an important crossroad, making the first steps towards a transition from fundamental science in plasma physics to technological and industrial reality. In recent years, we've seen a lot of investment from the private sector in fusion energy, with new startups entering the field. It is fundamental for the EU to nurture and support cutting-edge innovation in general, and in fusion in particular, again to push boundaries, to tackle head-on the issues that still hinder the realization of fusion as an energy source, produce new spin-offs for the benefit of European citizens and highly skilled jobs. The transition might be difficult, but it is necessary to move from pure scientific pursuit to industrial reality. And we need to make sure this is done with all stakeholders on board and playing their respective roles. Looking ahead, therefore, we see the need for an even stronger collaboration between industry and research, between the public and the private sectors, and the continuation of international cooperation where this leads to concrete mutual benefits. This needs to be done without forgetting that the completion of ITER construction and its exploitation is and will remain the highest priority for the European Union. Lessons learned from ITER construction, the experience of industry, that of fusion for energy, the knowledge and experience in the European fusion laboratories need to come together with a new entrepreneurial generation to move forward and tackle together the technological bottlenecks that need to be solved to make fusion a reality. Our ambitions are high and are obviously contingent on resources, stakeholder support, and industry innovation. The One JET team, through 40 years, have made an incommensurable, fundamental contribution to bringing us closer to our ambition. JET has been the symbol of the European effort, European in the wider sense. And in the last 40 years, it has been built, rebuilt, crippled, reborn, and it has delivered until the very end. The One JET team and JET now pass the baton to the One ITER team and ITER, as well as to a growing ecosystem of enthusiastic and ambitious blend of public and private initiatives. There are difficulties ahead, but we will not give up. We have not given up in the last 40 years. Now it is not the time to relax. It is the time to increase our efforts on all fronts together in one direction. Make transformational science, private and public collaboration, and international cooperation thrive in the years to come and turn the dream of the generations and our generation into a reality. Thank you.
Thank you very much, Dr. Righi, and welcome back. Next, we have Minister Bowie, who's the Minister for Nuclear and Renewables at the UK's Department of Energy, Security and Net Zero. Minister Bowie.
Thank you very much. It's a real pleasure to be back, and it's an honour to be here today. I'd like to thank very much UKAEA for hosting this special event, and thank you all for joining us here at Culham and also online to celebrate the most successful fusion energy experiment that the world has ever seen. 4 decades ago, in 1983, some of the very best scientists and engineers from across Europe arrived here full of hope and expectation. It was a period of great innovation and excitement. The internet, as we know it, had just been launched. NASA was busy exploring the wonders of the solar system. Aberdeen had just beaten Real Madrid to win the European Cup Winners' Cup. And very important, and fusion, the tantalizing idea that we could use the same energy-making process as the sun here on Earth, was gaining serious momentum. So these great minds from the UK, Germany, France, Spain, Italy, and elsewhere packed up their bags and moved here to Oxfordshire. Here they joined forces to create the world's largest operational fusion reactor, and the only tokamak capable of using deuterium and tritium as a fuel. Dr. Barry Green, one of the engineers on JET's first experiments in June 1983, and who I'm pleased to say is here today, remembers that moment fondly. It felt brilliant, he said in a recent interview. One thing is to work on a design, another thing is to operate it. JET was only supposed to last for a decade, but unlike shoulder pads and spandex, fusion never went out of fashion, and the constant success of this program ensured it kept being renewed for an incredible 40 years. In that time, JET has gone from first plasma to continually breaking its own world records. In a shining example of scientific cooperation, thousands of students, staff and experts from across Europe have played their part in Eurofusion experiments at this site. They have helped produce more than 100,000 pulses along the way, each time making this quiet corner of the English countryside temporarily the hottest place in the solar system. 3 years ago, JET set new records for producing more than 59 megajoules of energy over 5 seconds, more than double its previous record from 1997, demonstrating that we can create a mini star here on Earth, just for a few seconds. And in October, these records were broken yet again in the final JET experiment as it produced 69 megajoules of energy over 5 seconds. Now, to put that into context, that's enough power for 12,000 homes, produced by just 0.21 milligrams of fuel, the equivalent of a fraction of a grain of sand. To release that same amount of heat, you would need 2 kilos of coal. In other words, 10 million times more than fusion. So in a fitting swan song, that final experiment made us more confident than ever that sustained fusion power can be the solution to our future energy needs. And that is the legacy that JET leaves behind. The major scientific milestones and energy records produced here in Culham have not just increased confidence in tokamak as a design for future fusion power plants, and they haven't just paved the way for the construction of the world's largest fusion experiment, ITER in France, which aims to generate fusion at an industrial scale. Above everything, they have brought us so much closer to a fusion-powered future. Thanks to JET, we now know that fusion can be the safe, reliable, and sustainable energy source that we need. One which provides dispatchable baseload power complementing renewables like wind and solar. And one which promises to revolutionize energy production for countries without renewable resources, or with low land availability, or where traditional nuclear fission is not suitable nor politically acceptable. So thank you. Thank you to everyone who has played a part in this world-leading project, from those of you who worked in the very first experiment 40 years ago, through to the hundreds who continue to work on the site today. You have all contributed to the acceleration of fusion science through the international collaboration and engineering excellence. But the work doesn't stop here. JET itself will now move on to repurposing and decommissioning, which will last until around 2040. Rather than a simple decommissioning, this process is designed to repurpose valuable assets as well as providing a platform for research and development which will benefit the entire nuclear and wider energy sectors. And that will be vital as we begin to build a whole new generation of fusion facilities here in the UK, including the world's first civil fusion power plant just up the road in Nottinghamshire. The STEP, or a spherical tokamak for energy production, will use magnetic fields to confine the hot plasma from fusion fuels. And we're setting up a company, Industrial Fusion Solutions, working with industry and academia to build this unique fusion centre. At the same time, the UK Atomic Energy Agency will collaborate with Dell, Intel, and the University of Cambridge to develop a virtual prototype of that plant. They will explore how AI and supercomputers making up to 1 quintillion calculations per second can produce a digital twin of the STEP design. It's exactly the kind of science partnership that will make fusion a reality. And we want to ensure that we are continuing to work with our partners in Europe and around the world on this journey too. Indeed, our £650 million Fusion Future strategy sets out how we plan to build new relationships in this field over the coming months and years, including supporting the international efforts at ITER. In 2016, in an interview with the BBC, the late, great Professor Stephen Hawking was asked to describe the one thing that could transform our society. He could have chosen anything, but he chose fusion. He said it would provide an inexhaustible supply of energy without pollution or global warming. And JET has brought us closer to making that vision a reality. By uniting the best scientific minds in Europe for 4 decades, it has delivered breakthrough after breakthrough. Look, we're all aware of the joke that fusion is always 30 years away, and always will be. Unfortunately, JET's kind of ruined that punchline, because it is proved that fusion power works. And despite the huge challenges that remain, we now understand what needs to be done to create this near-limitless, safe and carbon-free source of power by the middle of this century. So thank you. Thank you once again for helping us to reach for the stars. Your role will not be forgotten as we begin to write the next chapter in this fascinating story. I began by mentioning Dr. Green and the joy he felt at seeing something he spent so long on finally in operation. I can only imagine the satisfaction you will all feel when, after decades of cutting-edge trials and experiments here in Oxfordshire, fusion begins to deliver the unlimited, clean energy that truly transforms our society. Thank you very much.
Thank you, Minister Bowie. Thank you, Dr. Righi, again for starting our celebrations today. So we are now going to move from the Taurus Hall here to the marquee. There will be a brief pause on the UKAEA YouTube channel. There's a new link available. After that brief pause, we will resume with some talks covering the whole history of JET from the marquee. Thank you very much.